Hey everyone, it's Frank. So today we're going to talk about putting some data that has no geographic context into geographic context, to bring it into the GIS world, data that actually kind of comes from outside the GIS world. Now, there's different ways we can do this. The method that we're going to do today is called georeferencing. So right from the name, you can see what we're going to do is we're going to go ahead and we're going to reference data into a geographic framework. And stick around through the rest of the lecture because at the end of the lecture, I'm going to have an exciting investment opportunity for you guys, and I want you to get in on the ground floor here. So stick with the lecture here, and I think we're all going to have a good time with this exciting investment opportunity that I'm going to bring to you guys today. But for starter, let's go ahead and take a look at what it is to georeference. Now, I'm going to go ahead and post up a link to the guide for georeferencing from the QGIS manual. But today, what we're going to go ahead and we're going to talk about georeferencing an old map. Not surprising, I am a geographer after all. One of my passions in life is actually old maps. And so I'm actually going to share with you a map that I've recently acquired, downloaded here. And this is an 1888. Hang on, do I have the date right on that one? This is an 1888 edition of the 1 degree quad, which covers Bozeman, Three Forks, and Ennis. So this is the Three Forks sheet from 1888. However, of course, this was before GIS systems, so this is not going to be an easy one to just go ahead. There is no georeferencing on this, so I can't just go ahead and bring it into my modern day map. So what I'm going to need to do is I'm going to go ahead and have to transform this into something that the computer can understand. There's a couple of ways that we can do this. We can do what is called heads-up digitizing, where we can go ahead and we can link visible features that are here on the map. Not a lot of folks living in Salesville or Moreland anymore. However, names may change, but certain things do stay the same. We will see that the locations of the Three Forks of the Missouri are, while they do meander around somewhat, it is a fairly reliable location. The other thing that doesn't move around a whole lot is actually these railroad tracks. It takes quite a bit of effort to lay down railroad tracks, and once they are in, they tend to stay put. And for the scale of the map that we're going to do, that we could actually use the towns as well. Keeping in mind that these are the old town centers here, but we can see that we can georeference to Ennis, Virginia City, Nevada City, Bozeman, and Three Forks. So we can get ourselves a decent spread of different locations here. The other way that we can do this is we can actually do coordinate georeferencing. So you'll see that on the map here, we actually have coordinates which are known, and we can go ahead and reference these onto the map by referencing. In fact, you'll see that here there's actually a tick mark here that we can go ahead and we can use that tick mark to reference to these known coordinates. So you'll see we've got 45 degrees and 15 minutes north, 45 degrees and 30 minutes north, 45, and then up to 46 degrees. So if I go ahead and I can reference these known locations here, in this case, 15 minutes is 0.25 of a degrees, 30 minutes is 0.5 a degree, 45 minutes is 0.75 degree, and up to here. So I can use these coordinates to georeference my map. Now, when I was mentioning the heads-up mapping, I think I probably should have mentioned that in the other order. But when I mentioned the heads-up georeferencing, what I want to do is I want to go ahead and link from their location on the old map to places that are still visible on the new map. And so if we take a look at, say, the river junctions here at Missouri Headwaters, you can see that, yes, the Madison and the Jefferson come together, and then there's a bit of river flow, and then the Gallatin comes on in. And similarly, if I go ahead and I look at the Three Forks here, we have essentially the same geometry here. So a georeferencing point put here to the river is pretty well known. So let's go ahead and take a look at how to georeference these things. So the tool that we're going to use is up here in the raster menu, and we're going to use the raster georeferencer. Now once again, I'm going to go ahead and I'm going to post a link to the manual for this. And I'm going to want you guys to practice this on your own. I'll give you a data set for this in a bit. So what I'm going to go ahead and do is I'm going to go ahead and drop from Windows here. I'm going to go ahead and drop my Three Forks topo. I'm going to go ahead and drop this into the georeferencer. Now, this map, because I'm going to try using the coordinates at first here, but one thing we have to keep in mind is there is absolutely no way that when they created this map that they were using Web Mercator as their projection system. So I'm going to go on into the properties here, and well, you can see I already brought it up, but I just happen to know, because I am a bit of a map nerd, that back in the 1888 year, what they were using was the Clark 1880 datum. And so you can see I've got several different options here for the Clark 1880, and I'm going to go ahead and just use the straight up unknown datum based upon the Clark 1880 ellipsoid. So I'm going to go ahead and redefine the coordinate reference system of my map into the appropriate coordinate system. Now this is not going to be important, and I'll switch it back actually when we do the heads-up georeferencing version of this, because at that point we're going to be actually referencing it to the visible space as it exists in whatever projection that we're using. But if we're going to be using the system where we go ahead and we use coordinate georeferencing, which is how we're going to start off, I want to make sure that I have my map here in the same coordinate system that the map was originally laid out in. So let's go ahead and take a look at our tick marks here, and I can see that we've got one here for 45 degrees and 15 minutes north, so that is going to be 45.25 degrees north, and we've got 111 degrees and 15 minutes west, so that is going to be negative 111.25 if I find this cross right here. So I'm going to go ahead and I'm going to, in fact, you'll see that there's a tick mark right there again. So I'm going to go ahead and I'm going to set my settings. In fact, I'm going to go ahead and start my georeference, and I'm going to set my transformation settings here. So before I do, you'll see I'm going to go ahead and I'm going to choose my transformation method. Okay. And there are a number of different transformation methods available. Now, if this is a very well orthographic map and we really just need to go ahead and, we know that everything is in the right projection system and everything, we can actually use a linear transform type. This is the easiest kind to use. It only takes a couple of reference points, and all we need to do is just tag our coordinate points on a couple of places on the map, and then the computer knows it goes in this place and it should be rotated at this angle. A linear transformation is the simplest involved. The Helmert is an adapted projected version of the linear version. There's also a polynomial version where we actually start to be able to warp and stretch the aspect of the input image, and using a higher polynomial, as you can imagine in doing regressions from say previous math classes, where when you go to higher polynomial, you can get a more complicated convolution to the way your map is transformed. I'm trying to change my camera here. So if we use a second order polynomial, that takes a few more ground control points, and if we use a third order polynomial, we need quite a few in order to get that to work. I think for the second order polynomial we need 6, and I think for the third order we need 9. But in this case, what we're going to do is we're going to go ahead and use a thin plate spline. Now what a thin plate spline is going to do is this is actually going to do what's referred to as rubber sheeting. As you can imagine, it's actually going to go ahead and take the map and stretch and warp and pull it. In the places where it needs to be stretched, it will be stretched. In the places where it needs to be compressed, it'll get compressed. This is very helpful in georeferencing images that need need quite a bit of adjustment to fit into the geographic context of our map here. So if I go ahead and I'm going to go ahead and use this thin plate spline because I don't really know how well referenced this map is to the real world. So I think for our first run at this, we're going to go ahead and do the coordinate referencing. And I'm going to go ahead and say OK, and I will say I'm going to specify my output is going to be coordinate modified. And we will go ahead and specify that. So I've set my transformation settings here. And let's go ahead and start adding points. So I'm going to use the add point tool here, and I'm going to start right from here and add this in, and I've already specified that this is going to be at, so the east is going to be minus 111. Oh, I just hit the wrong button here. Let me get back to my screen. So this is going to be 111.25, and my north is going to be 45.25. I'm going to make sure that my coordinate system is in the good old Clark 1880. And I'm going to go ahead and say OK. And you can see a little red dot has appeared. Let's go on up here, and I'm going to go ahead and do this in 4 different places on the map. And I'm going to add one right here. And this was, again, my east was going to be 111.25. And my north was going to be 45.75. I know because we already read the map. Excellent. Okay, so let me go ahead and get another one over here, and this is going to be at 111.75. If I zoom in on here, I will place my tick mark right in the middle. You can really run down a rabbit hole of trying to reference these sometimes. So this was 111.75, 45.75 north. And let's try our last spot where this was 111.75, and then north is 45.25. Okay, so I have entered in 4 different coordinate ground control points here. You can see that I can go ahead and I have different options to go ahead and delete those points or move those points if I need to. I'm going to go ahead and I'm going to run my georeference here. And let's see what happens. Okay, so this was a successful georeferencing. And not enough GCPs. Thin plate spline requires at least 1 ground control point. Let me see here. What did this do? That should be enough. I'm going to take a look at my output. And it did produce an output. So my output is going to be, I'm going to go ahead and drag this onto the map. And if I look here, aha! So as we can see, this actually has gone ahead and dropped the map. Let's go ahead and give this a little bit of transparency. Here we go. And let's take it down to about half. And as you can see, yeah, we've got fairly decent alignment for where, let's see here. Here's where the river is, and not too bad, not too bad. Let's take a look at where Bozeman is. Yeah, you can see that the old eastern side of Bozeman is the part that got added in. The part I'm really kind of curious about is how well does it lay down with the railroad tracks. Not too bad, not too bad. It's off a little bit here. And And if we go ahead and we take a look down here, of course, this map predates the creation of Ennis Lake. You can see Ennis Lake in the background there, but you can see maybe the town side of Ennis is off a little bit. So our georeferencing, while coordinate-wise it was dead on, we have to keep in mind that the surveys that were happening back in the 1800s were, of course, happening with little bits of metal and glass. They did an excellent job. They did the best they could. They did a better job than I could have with little bits of metal and glass, but of course we can do better than that nowadays. So I'm going to go ahead and I'm going to remove that layer here. Let's go ahead and take that out. And I'm going to go ahead and I'm going to start an all new georeferencing here. So you can see I've got my ground control table here, and I'm going to go ahead and take these out. Let's go ahead and remove those points. Okay, so we're going to start this whole process over again because while that was a pretty decent alignment, what I really want to do is I want to go ahead and use the capabilities of this thin plate spline to actually warp and stretch the map a little bit to actually make it fit the map. So I'm going to go ahead and change my output here to I'm going to go ahead and call it rubber sheet modified. Okay, and let's go ahead and do a little bit of heads up digitizing. So I'm going to find, we did mention the first areas that got surveyed out here in the west were the rivers. So they were pretty good at locating rivers here. So I'm going to go ahead and I'm going to start one from the river, and I'm going to go ahead and click from one here. And then you can see that there is an option here to map from canvas. And so instead of entering the coordinates here, I'm going to go ahead and I'm going to map from the canvas. And now I'm going to go ahead and find on the map the correlating spots. So let's go ahead and zoom in. And oh boy, there is a river in the channel now. Of course, the Gallatin River has probably migrated a bit. I'm going to go ahead and set that right about here. Okay, and I'm going to accept that. Now let's go on and find another known location. Well, let's go ahead and take, the town side of Venice is one thing. I think I'm going to go ahead and I think a smaller and more historic spot is going to be the location of Nevada City. It also really helps when you guys are picking your spots to georeference to spread things out a little bit. The analogy of a footstool is good. Putting things down in triangles is always adds a little bit of stability. So here I can see the town site of Nevada City, so I'm going to go ahead and put one right here. And I'm going to accept that. And let's find a third spot, but I'll probably actually go for a few more than 3 because I do want this thing to rubber sheet a bit. So let's see where else we can find that is a known location that's still going to be on the maps from the days. Well, Lone Mountain. Mountain peaks, of course, were probably very well surveyed, so I'm going to go ahead and I'm going to pick the very peak of Lone Mountain. And let's find us Big Sky. Ski season just ended, and I didn't get to Big Sky more than once this summer, or this winter, but I think I can still go ahead and find on the map there. It's Big Sky, and we know it's up in the mountain village. Here is all the different ski runs, and there is the peak mark for Lone Mountain. So I'm going to go ahead and I'm going to put that right there. Okay. So that's with 3 I could probably go ahead and start, but I want to give it just a couple more because I do want it to warp and shift this a bit. Let's go ahead and take a look. Oh, you can't get away from the bear trap. Anybody who spent any time in Bozeman, you're familiar here with the Bear Trap Canyon. And here is where the creek comes out of the bear trap. So I'm going to go ahead and mark this one right here. And let's go on here and find that bear trap. That is where the river comes out of Ennis. And I think the creek has been moved a little bit more. If we took a look back there, you know what, I'm going to go ahead and I'm going to put that right about here because it was there on the bend, if I recall. Yeah, so I think I'm going to go ahead and leave that there. We'll see how the rubber sheeting handles this. Um, I'll show you a bit about the residuals here in a moment. Because of course this is not going to be perfect, so it's actually going to come up with some residual errors and report those to us. Let's go ahead and take a look at, let's see if we can identify that bend in the tracks just to the north of Bozeman. Let's see if that's possible. That's the kind of thing that isn't going to go away. So let's go on up here to Bozeman. Let's find those railroad tracks where they come in. Aha! There is that inflection point right about there. And let's see if there's anything else that might be identifiable. Some of these, my goodness, there's the town of Willow Creek. That might be a good one. I don't know, though, because I don't know which is the oldest part of Willow Creek. I could try the town side of Three Forks, but anybody who's actually been around Three Forks know that that's at a certain point in time they actually picked up the town of Three Forks and moved it because that original location used to flood. And so I think we're going to go ahead and leave that alone. This whole area is under Ennis Lake now, so that's not going to give us much. Let's see if there's anything else. This junction between Indian Creek and the Madison might be decent. Let me go ahead and put that one in. And let's take a look here. Well, I thought I had a pretty river-friendly version of this map, but maybe I'm not going to find Indian Creek here. Nope, I think oh, possibly. I just need to zoom in a little bit more. Which one is this? It's Curlew Creek. There's Moose Creek. All right, I'm going to go ahead and hit escape because I am not seeing. All right, so that's not going to let me escape out. So I just right clicked on the mouse and that took me back out, and I'm going to go ahead and cancel on that one because it looks like the river names have changed. I was definitely going down below the wedge, so I think I might go ahead. I could probably get the Sphinx. I don't know how that's going to show up on my map. Yeah, you see, because things do change. Because here's one labeled Highlight Creek or Highlight Peak, but that is definitely not the Highlight Peak that we know about today, which is up here by Mount Blackmore. So do have to be careful about those. Yeah, maybe I'll go ahead and put one here where Spanish Creek comes into the Gallatin. I think that should definitely show up on the map. So let's take a look over here where Spanish Creek comes into the Gallatin right about here. All right, so I've got, and let's go ahead and take a look at my ground control point tables here. And you can see I've got a number of source and destination X and Y's. This is an opportunity if you're doing the coordinate georeferencing, you can actually go ahead and fine tune and edit your destination X and Y's if you want to at this point. I'm going to go ahead and I'm going to run my georeferencing, and when I do, it will actually calculate the various weights of the, I guess it's not going to do this with this, but it'll do this with the polynomials. So okay, it ran this, and I'm going to take a look at my rubber sheet modified, and let's take a look at what we got. So looking at the rubber sheet, and let's go ahead and give this some more transparency here. Where is my properties and my transparency? Let's take this on down to, yeah, let's take it down to 45 so we can see. And so very nicely we can now see that Salesville exists, where is now the town of Gallatin Gateway. Once again, Bozeman is showing up nicely here in the eastern side. And you can see a little bit of weirdness going on here. This is not quite going on a straight north-south line, but take a look at the agreement. Oh, this is looking really good. The agreement of the Madison River looks really nice. Ennis, the town site of Ennis is much closer to where it shows up on the map these days. If we take a look over here, Nevada City is showing up really nicely onto the overlay of the old map. In fact, you can see that there. And Virginia City is showing up pretty well as well. Let's take a look up here at Norris. Here's Red Bluff. Some of you at the university are familiar with the Red Bluff ranch for the university, and we've got the hot springs here. So I think we've got a pretty good georeference here. So I can go ahead and I can save this now. And so this is now something that I can go ahead and I can include on any of my modern map products. Now that I've georeferenced this, I'm free to go ahead and let's go ahead and go back to here. And if I want to, I'm free to go ahead and let's add on some data from a RES service. I'm going to go to the Montana State Library and let's look at our transportation, and let's go ahead and put on, go ahead and drop our roads on top of this historic map. And let's go ahead and turn my transparency kind of back up a bit here. And so now what we can do is we can take this kind of cool old historic map and we can drape our modern infrastructure on this. You can see that the historic town of Moreland is actually the town of Manhattan now, after it got renamed. We can see the Jefferson River, and yes, I did mention it's a good thing we didn't use Three Forks as our georeferencing point, because you can see here is where the old town of Three Forks is. In fact, that's what it's called these days, and here is where the current location of the town of Three Forks is. So this is an excellent way of digitizing some things for use in change detection, as well as just kind of bringing in some cool, some cool visual here. The other thing I think I'm going to do right now is I'm going to go ahead and bring this back into a more modern projection system. So I'm going to go back to my project and my properties. And I think I want to go ahead and set this back to the WGS84 pseudo Mercator, the web Mercator there. And now you can see that, oh, that looks a little bit better rather than doing anything in the just straight up old geographic coordinates with that Clark 1880. So this is looking pretty cool. You know, I like, oh yeah, look at that. It's a good thing I didn't use Willow Creek, because the current town of Willow Creek is up here and the old town of what they might have called it is actually down here. So you always got to be a little bit careful. Make sure you choose something that was fairly well surveyed and is fairly persistent on the map. So I hope you like the introduction to georeferencing here. So this is going to bring me to this exciting investment opportunity that I wanted to bring and share with you guys. So for our last exercise, now that you guys have watched the video and I want you to go ahead and look through the manual and all, I'm going to present you guys with a bit of a geographical conundrum here. Once again, I love old maps. I'm a geographer and I just can't get enough of looking at these great old artifacts of our past. And here we can see this is the 1814 rendition by Samuel Lewis, no relation that I'm aware of, but this is the rendering of the maps of the Lewis and Clark expedition. This was done several years after they got back. The maps and journals were all referenced and compiled, and they actually went ahead and entered in, and Samuel Lewis worked with William Clark, who is just a mapper extraordinaire. This guy just did fantastic work. They estimated their trip to be 4,040 miles, I believe, and the measured estimate of what they actually traveled says that he got it within a couple of percent. So it was really an extraordinary job of mapping. Now keep in mind that they kept a river course, so their accuracy along the river, starting here at the junction of the Missouri River and the Mississippi River, their knowledge was firsthand and their surveying was quite accurate as long as they were along the river. As they get a little further out, they were working, compiling secondhand maps that were drawn by French traders and Native Americans that they encountered along their trip. They were interviewing and collaborating with people the whole way along. And so their accuracy along the river is quite good. And then as they get a little further away, it gets a little bit more speculative. So what I want you guys to do is I want you to georeference this map, and your better locations and more identifiable locations are generally going to be, I would suggest, using river junctions. These major river junctions, like here the Platte River, the Kansas River, the junction of the Yellowstone and the Missouri, the junction of the Marias River and the Missouri River. These were all very well surveyed and documented. Even the location at here, where they wintered at the end, Fort Clatsop here at the location that they named Cape Disappointment. These are the places where they saw, and so they got quite accurate. The investment opportunity I want to bring to you guys is I want to bring your guys' attention to a particular spot on this map in the lower left-hand corner. And this is a spot known as Lake Riddle. This is a lake that was documented by Lewis and Clark through their interactions with Native Americans and all. And the thing is, nobody in Idaho knows that this lake exists. We have an opportunity here, guys, to get in on the ground floor of buying lakeshore property in central Idaho that nobody even knows there's a lake there yet. So in order to find this map, find this lake on the map, what I'm going to need you guys to do is georeference this Lewis and Clark map into our modern day map. And then what I want you to do is I want you to go ahead and digitize, trace the outline of Lake Riddle. And the riddle is, how is it that nobody in Idaho even knows that this lake exists? I have checked. They don't have any mention of Lake Riddle in Idaho. So what we're going to do is we're going to go ahead and have you guys map it, and then we're all going to go ahead and pool our money together, and we're going to buy lakeshore property in Idaho when the Idahoans don't even know that there's a lake there. I'm brilliant. I don't even know why I'm teaching school. I should be a real estate developer. So this is what we're going to have you guys do. So I want everybody to go ahead and digitize the location of Lake Riddle. In order to do this digitization, I want you to georeference this map, and then kind of go back to your layer creation from, I believe it was chapter 2. I want you to go ahead and create a new polygon feature probably in a geo package. Let's go ahead and say I want you to submit a geo package that contains an outline of Lake Riddle, and I'm going to go ahead and I'm going to composite all of your maps together, and we will figure out the extent of our mystery lake here, so we can go ahead and we can start buying up some land. Okay, so let's go ahead and get working on this. I'm going to go ahead and post these materials up to the D2L. And also I want you guys to produce a map of Idaho showing me where Lake Riddle is, so we can go ahead and we can all drive on down and find what highways, and also produce me a map, and also submit me a geo package with your actual data in it. Okay, I don't need a submission of the georeferenced Lewis and Clark map. That you can have for your own posterity. You can hang it up on the wall of our new lakeshore cabins after we buy them and build them. So after we're all done, I'm going to go ahead and I'm going to compile all the data together. So I want you to present to me a map and the digital feature of the lake. Okay, so have fun with this, and I will talk to you guys soon.